just wanted to mention a few words, especially to the young people here, about the recipients and why they received it. Apparently it's a mix of very different areas of astrophysics, and one may wonder why they mixed it. I have actually my own suspicion, but I will not spell it out. What I wanted to mention is, let's start first with, well, Jim Peebles, who is a pioneer in understanding the universe. He was a student of Bob Dickey at Princeton. In 1964 is when he started working with Dickey. Bob Dickey established basically the gravity group at Princeton, and they started they wanted to measure the cosmic radiation left over from the Big Bang. So they designed an experiment, and Peebles calculated what kind of radiation, the details of the radiation, and the fact that when electrons and protons get cold enough, they will make hydrogen atoms, and then the microwave background will be able to go through that. And they were getting ready to measure it, and at which point a professor at MIT told them that the experiment was done in Bell Labs by Penzias and Wilson. So they were scooped. That was around 1965. Peebles started in 1964. And then after that, Peebles did important calculations about the growth of structure in the universe, how small perturbations grow and become the structures that we see now in the form of galaxies or on very large scales. A very fundamental process. He wrote some seminal papers in the late 60s and early 70s. And I should say at the same time, there was a group in Russia, in Moscow, led by Yakov Zeldovich, that independently did the same things, and according to Rashid Sunyaev, they did it first. So actually Rashid should have been recognized as well by the Nobel Committee, but they have a limit of 4. And why they mix these two fields, I have a conjecture. At any event, that's Peebles, and he is highly respected for 55 years, worked in this subject and pushed. And he was among the first people to actually propose cold dark matter. Andy, there is a chair here. Or here. He was among the first to propose cold dark matter, that the dark matter is cold, meaning that it started with very small initial speeds, the dark matter particles. So Peebles was among. He also was wrong on some occasions. For example, he argued for a decade or so that the dark matter may be baryonic. That was his favorite model, and that model was ruled out. But he is perhaps the most influential living cosmologist of our time, in theory, theoretical cosmology. And many of his predictions were confirmed by experiments. And he is also an exemplary intellectual, a gentleman, very kind to young people. And he was asked, so I woke up at 5 a.m. today to listen to the Nobel Committee, and he was on the phone, and they asked him, what would you, that was a Chinese reporter, asked him, what would you recommend to young people entering physics or science? First thing he said was that it's very important that experiments play an important role in physics and help us arrive at the truth, which is very true of cosmology. But the second thing is that you need to do it for the love of it. Forget about prizes. You should never do it for that. You should enjoy you should have a passion for the scientific knowledge. And I think he serves as a role model. Jim Peebles is really a very kind and generous and thoughtful and truthful person. Anyone that knows him will say that. And I had the fortune of actually collaborating with him about 15 years ago when I was on sabbatical at Princeton. The other two that got the Nobel Prize are Michel and Didier, Queloz, who was a student of Michel in Geneva when the discovery was made. So it's very different. They made one important major experimental discovery or observational discovery. Jim Peebles was a theorist that worked for 55 years. And their discovery is the first discovery of a planet around a sun-like star. So it turns out, there are two anecdotes about this. First, that a planet was discovered before them around a pulsar, a neutron star. But they were the first to discover a planet around a sun-like star, which of course is important because there might be life around sun-like stars. We don't think there is life around neutron stars. The second interesting anecdote about that is that theoretically, the method that they used was predicted to be successful 40 years earlier. 1952, there was a paper by Otto Struve, who was an American astronomer that wrote a very short paper saying, if there is a planet like Jupiter around a star like the Sun, and it just happens to be closer to the star than Jupiter is, much closer, then it will move the star back and forth as it moves around it at a detectable level that we can measure. And for 40 years, since 1952, when this paper was written, for 40 years, time allocation committees on telescopes said, it's a waste of our time. We don't want to look for that because we know why Jupiter resides where it does. We don't expect Jupiters to be close to their stars. So let's not waste telescope time, let's not look for it. There were proposals to observe such things, but nobody gave time on telescopes until these two people looked at the 51 Pegasi, a star that happens to have a hot Jupiter. And that opened the floodgates of discovery. So since then, with the Kepler satellite, we found thousands of exoplanets. Just to show you that prejudice is dangerous, even in an observational science like astrophysics. If you think you know the answer in advance and you don't look through the telescope, you might miss an important discovery, a Nobel Prize worth discovery in this case. So these two people were the first to actually search, have the sensitivity and use it to search for a Jupiter-like planet next to a star and detect it by the Doppler motion of the star. This discovery could have been made decades earlier. So again, extremely important because it opens a path towards discovering life around other stars, which is a very important question that we have in science. So I would say that all three represent major intellectual leaps that we had in astrophysics over the past several decades, and we are very proud to have all, and also to have a former graduate student being recognized, because when pulsars were discovered, the graduate student was not recognized by the Nobel Committee. That was 4 decades back. So we are very happy and glad that the Nobel Committee is also recognizing this as part of physics, because astronomy was for many years not always recognized as part of physics. Okay, that was my 2 cents about today's Nobel Prize. Now we'll